Alright guys, so I hope you are clear with the decision tree with the Guinea index part, and you know how to split it on by if you see the example which I have given. I hope you are clear with how to split that on the basis of gender and on the basis of age, and how to choose on the basis of Guinea, which is very close to the Guinea index value, which is very close to 1, or which whatever the value which is higher, you choose that and you split on the basis of that. I hope you are clear with that. So in this lecture, we will be moving forward to another concept, which is your information gain. Alright, so we calculate information gain here with the help of entropy. Just write, we calculate with entropy. Okay, so entropy here describes the degree of disorder in the data. Entropy tells the degree of disorder or disturbance or noises present in the dataset. So basically this is entropy, which is entropy's role here in information gain. And like I have explained at the last of the previous video, like in Gini index, value of entropy is also lies between 0 and 1. Values between 0 and 1, and however it is completely opposite to your Gini index. What I'm trying to say is that if entropy is inversely proportional to your Gini index, that is, if data is completely homogeneous, if the data is completely homogeneous, then your Gini index will be 1, as I have explained in my previous lecture. So your entropy will be 0, completely opposite. Okay, so this is the like introduction of information gain here. It is calculated on the basis of entropy. So there is also a formula here, a small formula like your Gini index, a slight change into that. So I'll just erase this. So your entropy of the given data is minus iterating I1 to k probability log of probability, and log here base 2, always remember base 2. And why why negative sign here? This is because my value will be always between 0 and 1. Like I have already said, my entropy value will be always between 0 and 1. So log of any values which is between 0 and 1 will be a negative value. So to make the entire thing positive, we add a minus negative in front of it. So negative negative is plus. So this is why I have added negative, and it is like it is there in the formula negative. And so why it is negative, that I have explained. Okay, so some basic points I must write it down, like to remember, like Gini index is a measure of your homogeneity. Entropy is maximum when Gini index is minimum. Like I have explained, it is inversely proportional to each other. Third point, I can say entropy is 0 if probability is high, like 1. So obviously it will be 0, entropy will be 0. So now let me tell you how to calculate information gain now. Okay, so I'll just erase this again. Okay, so let's say I have a subset of a decision tree. This cell or this leaf has entropy as E and it has entropy as E dash. Entropy has decreased here. We will be having some entropy here. Like initially we will be having E, and after splitting, let's say I got entropy as E dash. So my information gain here will be E minus E dash. This will be my information gain. This thing you have to remember. And what exactly E minus E dash means is that I want maximum gain, which means I want to reduce my entropy as maximum as possible. As maximum as possible, I'll reduce this entropy. You remember, right? If entropy is reducing, then it will be more homogeneous, and we want the homogeneity to increase, right? So it is inversely proportional. So we want to gain a maximum entropy. Okay. So to explain this, I can give an small example with calculations as well. Like how will we doing that? So let's say I have a decision tree which is further divided to this, and I have, let me take okay. So first we have in our parent leaf we have four circles, two of blue color and two of purple color, and after splitting, each one has one like same colored things. Like here you can see homogeneity. Like if you look, homogeneity is one here. Like in my previous lecture, I have explained this such example, not this, but very similar example there. Now here you can, like by looking you can say homogeneity is one, right? So how we can say by using information gain, how we can calculate that? Just have a look. How we can say all this? We'll put just values in my formula. ED is minus 2 by 4. You can see here probability is 4 because 4 circles are here, and we'll take for one part like 2 blue one, then we have log 2 2 by 4, simple formula, and we have 2 by 4 log 2 2 by 4, and if you solve this we'll have value as 1. And then we have, after splitting, let's say after splitting we have entropy as EDA, which is your minus 0 0.5 1.2 1 by 2, yeah, 0 0.5 into log 2. Here we have 2 by 2 because we only have 2 and total is 2, minus 0 0.5 log 2 2 by 2. Here you can obviously say it's 0 because log 1 is 0. Here it is 0. And what I have explained, that information gain is nothing but your ED minus EDA. 1 minus 0 equals to 1. So what you can find with this, it means it is completely homogeneous data. So that's what I have explained at the starting. Like after saying this, we can see it is completely homogeneous because it has no, like this is next to impossible in real life. But to give an example, by looking, I have explained how it is completely homogeneous, and after solving also, I have proved that it is homogeneous. It is coming homogeneous, and which is a very good information gain in this case. Like you can say, it is a very good information gains we have received. In real life, it is next to impossible. There might be cases which is very close to it, but no, we cannot say it. There will be a lot of values like this. All right, so I'll just erase this. I hope you are clear up to this. Okay, so now what I can say it here is, guys, if you remember, I've shown you one example of the same example of the uh, playing football, people, males and females, and on the basis of gender less than 50 and greater than 50, I've given you an example there. If you remember that example, like I think I should draw it again. Mm, you can, guys, you can take out the your notes and look into that. I'll not draw. I'll just look it into my notes and I'll just explain you there. You just make take out the note. Like it will take a lot of time if I draw each and everything again. So, please open all the notes where you have drawn that square box with subdivided into square and female, male, basis of age and gender. We were doing finding the Gini index. We'll take the same example here, and from there you can see 300 by 310 by 1000 is people play. This is my probability that people are playing total, and 690 by 1000 will be they don't play. You can like simply find the probability. Total is 1300 are playing and 690 are not playing. Okay, so let's put this formula, like put these values into the formula for the initial part. Let me just put all these values. If I want to take on the basis of age, I'll say 310 upon 1000 log 2310 by 1000 minus 690 by 1000 log 2 690 by 1000. Okay, guys, you calculate the value. Values are not important here. I'm just trying to explain how it is done. So for gender and for females, you have to do like 1 by 2 or 0 0.5, 10 by 500 log 2 10 by 500 minus 490 by 500 into log 2 490 by 500. This is how you put the values in this formula of uh, I hope you are getting what I'm trying to say. Okay, log 2 by 400, and similarly for male, this is for female and this is for males, 0 0.5 into your 300 divided by 500. Just look at the values in your notes. I have not drawn this again because it will be time consuming. 500 minus 200 500 log 2. If you want, you can calculate the values. It is a task for you to find the values and then subtract and find the information gain here, which whatever is the highest information gain, you will split on the basis of that. So, and if you don't want to do the calculation and all, I seriously have no worries, because the good news is you don't actually have to calculate anything into machine learning. Everything will be taken care at the back end by Python packages. So you don't have to actually calculate. That is why I'm not calculating all these things, because everything will be covered and taken care by Python packages at the back end. You just have to give a one line code and everything will be covered. All right. So this is the thing here. So please make a note, like formula is important, like it may ask you into your interviews and all. So just make a note of all the formulas and all, and how to put the values. And guys, you should know the basic probability, how to find the basic probabilities and all. Okay, so I'll just erase this. Now let me tell you some advantages and disadvantages of decision tree. Like everything has, if there is an advantage of anything, there might be disadvantage for that, right? So I'll just divide it. Advantages, and whatever I'm like, before practicals you must have noticed that there are 2 or 3 lectures of theoretical part of before every practical I do, and these practicals are basically nothing but the things though that are widely asked and can be asked in your interviews. So I'm preparing you for on the basis of that, because without interview you cannot join any company unless until it's your own company, right? All right, so we have advantages and we have disadvantages. So let's see the advantages first. What advantages we have? Okay, so the first advantages is it is easily interpretive. You guys can make a note of all this. Like we can interpretive means like in a decision tree, if we are putting a value into one cell or leaf, we can finally interpret like what can be in the next cell. Like if it is yes, it can be this, and it is no, it can be this. Like it can be, it is easy. Second is it can handle, like I have already explained, it can handle categorical and numerical values very easily. So can handle categorical, numerical, as well as Boolean, strings, and many more. It can handle easily all the values. Any type of data it can handle. So this is obviously an advantage, right? And then normalization is not required here at all. Not required here, normalization. Then it gives importance to all the attributes. Yes, importance to attributes. Then we have fifth, we have decision tree is relatively little, like can say it will like, I'll just write it down. Less effort for data preparation. Like if you're preparing any data, relatively it takes less efforts for the users. That's what I'm trying to say. And sixth and the last one is it can handle nonlinear relationships between parameters and do not at all affect tree performance. Nonlinear relationships between parameters do not affect the performance of the tree or tree performance. These are some advantages of decision tree. So if there are advantages, there might be few disadvantages as well. If anything is not perfect. So the first disadvantage is the most important one, and this is the most important disadvantage. Not like cannot say important one, like this is the advantage, which is your overfitting. It is possible in this decision tree whenever you are trying to make a decision tree, overfitting is we will see a lot of cases where there is overfitting, and why this is happening, because if there is a noise in the data set or any disturbance or missing values, there will be overfitting. Okay. Second is unstable at time, and because of overfitting it can be unstable, right? Because it is growing and growing and growing, and if you remove change any value from any part, if you change any value, like it's overfitting, so you reduced or deleted some rows, so it will be unstable at the last. So this is what happening. Third is it is low bias. It like a highly complicated decision tree tends to have a low bias, which makes it difficult for the model to work with new data. Okay, so these are the few advantages, and advantages are more and disadvantages are less. So that's good. Like, so overall decision tree is good. So I hope, guys, you please make a note of all this and try to understand in your own words, in your own language. And this is asked in interviews. Like some of my previous students, uh, like like asked me to explain advantages and disadvantages as well, because they have been asked in one or the other interviews when they are working giving interviews on machine learning. So it's been asked. Okay, so I'll just erase this. You can pause the video and make a note. So there are some of the other techniques as well to avoid overfitting, and the best one is your regularization. I'll just make a note of it. uh, just give me a minute. To avoid overfitting, there is a technique called regularization. Okay, so what basically it do is it helps to reduce the complexity of decision tree. So like it that you will that you will be seeing in further coming lectures how it do. And there are two ways to do that under this. Basically, like there are two parts under regularization how we reduce overfitting. First one is your truncation, and second one is your pruning. Okay, so truncation is nothing. Let's start with truncation. So truncation is nothing but when the tree is growing, like it is growing up at that time only we prevent it to grow too deep. Like whenever the tree is growing, so like when it's in the growing state, at that time only we'll take some of the other step, like, and we'll say, okay, I don't want it to grow now. Let's stop it there. So if I want to give example here for the truncation part, if this is my tree and it started growing, okay, this is growing, growing, growing. growing, growing. Now I said, okay, full stop. Stop now. This is enough, and I have sufficient result for this. I'm okay with this result. Stop now. So how to stop that? We will be putting some criteria here. Criteria here to make it stop and to make the like basically to stop the growth of the tree to grow further. We'll stop it here. And pruning is completely different, like opposite, not different. It opposite. Like in this case, we let the tree to grow as much as it wants. Like we will be allowing it to grow completely, and after it is completely grown, like it is done, we will now remove the unwanted part. And how to do that, that I will be explaining you in later lectures. But just give you one small example here. Like the tree is growing, we won't say stop now. I will allow it to grow. So it will keep on growing, keep on growing. It will be keep on growing. It will be very complex. You can see it's so complex, and maybe they'll grow more, maybe more. So we'll allow it to grow, keep on growing. And now after some point we'll say, okay, so we don't want this. Okay, so we won't want this section. So here, what we do here, we look at the fully grown tree and remove the unwanted part. So like I said, okay, this part is not that much required, so we'll remove this. So entire this branch of the tree at the bottom of this will be removed. So what we will be doing, we'll start looking from here at the bottom, and we'll see, okay, from here up to here, this is not required. So this is the thing we will be doing in under pruning, and this is also known as bottom up approach. You can remember as bottoms up in any parties. So this is the basic introduction of truncation and pruning. What I'm trying to the in depth I will be explaining you now. Okay, so this is the basic thing. What happens? So now let's see truncation. Truncation. So now let's see what is exactly. Let's go deep into truncation. So under truncation also there are several ways which can be used to prevent overfitting basically, and the first one is minimum partition. So let me just make a note of everything. Minimum partition. In this we set the minimum size for the partitioning, like we are setting some sort of minimum values, and and we as soon as we achieve it we achieve that value, we stop it there itself. So this is minimum partition. Second is we do minimum homogeneity. On the basis of homogeneity, like again we set up a value of homogeneity as h, and as soon as the value of h is about to reach, because h cannot be 1 completely but it can be reached any value, like let's say if we have assigned the value of h as 0.9, and as soon as is achieved, we'll say stop there itself. This is how we do. Okay, and there are like these are the two most important one. There are many other like limit tree depth, will not even increase the depth of the tree, will just initially will assign the depth of the tree, and minimum leaf nodes, and here as the name suggests we'll assign number of leaves before itself, and that's much only it will grow. The number of leaves which we are assigned, it will grow that much only. Okay, So this is how truncation works. Now let me explain you pruning. So let me just make a, I can do it here, yeah. We don't have to rub it. Okay, so pruning. Pruning, as I have suggested, we will allow the tree to grow completely. Let me just draw it. This is not a part of. Alright, I'll draw it here. I'm very choosy with the colors, guys. Please don't mind. Okay, so let me just draw one a good tree. And like if you remember, pruning is nothing but we don't stop it in between. We don't interfere when it is growing. But after it's fully grown, we look it from the bottom and then we suggest like, okay, this part is not, we don't want this part. So we'll remove that part. So this will be very complicated as you can see. Let it grow. So this is how it grow. It will be keep on growing. Okay. So all right. So how to explain you here is okay. So we started looking from the bottom here. Started from the bottom, now we here. Okay. So we started from the bottom and now we here. Okay. So and let's say we came up to here at this point, and like we're gonna remove this full node from here, and all the values like these values, whatever the values are here, we will be transferring everything like from here. I want to remove this entire thing, right? So but we don't want the values, like values will not be deleted. Instead these values will be somewhat changed, that I will explain you what happens, and it will be like transferred in this leaf. Everything will come into this leaf and rest the tree will be shortened up. This is how it exactly works. The pruning part. I hope this is clear. Like this is the easiest way I can explain the pruning part, but the theoretical part just try to explain into this way, but you will be cleared with when we will be doing the practicals. Okay, so the question here is where do we prune? Like how I know? Like I want to prune it here. Like I know I will be going from the bottom to the top, but where we will be pruning? So if you remember, I'll just erase this. If you remember, three important things that we have, like that we have studied. One is your training, cross validation, and testing. If you remember these things, so we will be taking help of all these to find the pruning, like where to prune the data. And you know the training set, testing set, and cross validation. If you remember, the cross validation is nothing but we were using it for hyperparameter tuning. If you remember the hyperparameter tuning part, because I'm writing it because it will be used a lot. Hyperparameter tuning. So these three, if you remember, these three will be used a lot during the tuning. And once we prune the data or the tree, the part of the tree, we look for the accuracy now. Like after the data is pruned, after pruning, we look for accuracy. Accuracy. So if I want to say, let's say accuracy A1 is, we found that we have the accuracy as A1 before pruning, and accuracy A2 after pruning. So if A2 is better or equal to, like if A2 is better, or like you can say greater or equal to A1, we will allow it to prune at that point. This is how we do the pruning. Okay, so A2 should be like after pruning, our accuracy should increase. Obviously, it should increase, right? That is the main motive of everything we are doing. And if A2 is increased and then A1, we will allow it to prune, and if not, then we may retain it. So we keep on iterating and find the values like this. I hope you are clear up to this. Okay. So since we will be working a lot, since we will working like everything will be working with Python, we have some parameters here. So in Python, we have some parameters here, which we will be using a lot in our coding. Like first one is, there are many actually, but the most important one, I'll just make a note of it. Criterion parameter, in which you will pass into the, you'll pass like Guinea or your information gain or entropy part. You'll pass this into the parameter. Then you will be having max feature parameter. Then there is one max depth. Then you have minimum samples split, and you have there is one more important, minimum sample leaf. So there are many other, but these are the most widely used parameters which we will be using a lot into our Anaconda notebook that you will be seeing into the next lecture, which I have explained a case study, like a real-time project, where I have explained each and everything, how to make a decision tree, and first simply make a decision tree like a default decision tree, which is very bad and looking like very complex, very complex. And then we start like we have introduced the parameters to reduce the complexity of it and everything. So everything you will be seeing in the next lecture, which will be your project. So I hope you are clear up to this, guys. This everything like your Gini index and your information gain, entropies, everything you are clear up to this. Homogeneity. So just keep revising, and I would request you to like revise this video, this lecture, and the previous lecture. And if you are not clear up to this, revise it again and again. Like watch it 2, 3 times, 4 times, 5 times before going to the next project part. Because if you are not thorough with this, you'll not understand the project at all. Okay, so if you want to do the project, just go through all these things, because I will be using a lot of terms which I have explained in these two recent lectures into this. Alright guys, so I think you guys are making note of everything, and if you have any doubts, you can anytime ask me anywhere. Like there are many other things you can ask me on Udemy message box, or you can even send me a mail, or if you want my personal number, you can send a mail and ask me for my personal number, and you can anytime call me if you have any doubt and you want to understand anything. All right, so I'll just end the video here, and let's move on to the project then. Thank you so much.